In this video, I introduce two important concepts in denoising diffusion models. A dataset consists of ID samples xi from unknown data distribution p data x. The score of probability density px is defined as here. A score network S set is trained to approximate the score of pdx. Score-based generative model as a set is trained on the dataset to learn to generate new samples from p data x. Score matching is designed to avoid computing intractable partition function in generative models due to gradient used in the score matching. Score matching objective is to minimize this expectation. However, score matching is not scalable to deep networks and high-dimensional data. Denoising score matching is a variant of score matching, which further perturbs the data point with a pre-specified noise distribution Q sigma, and then score matching is applied to estimate the score of the perturbed data distribution as shown here, which diffuses data distribution p data x to a noise distribution q sigma x tilde over latent variables x as shown here. The equivalent score matching objective is defined as here. The optimal score network S theta as a risk satisfy this equation, which points to an optimal direction for the score matching models to produce samples starting from a normal distribution. However, this equation is true only when the noise added each iteration is small enough so that Q sigma is equal to P data. Langevin dynamics can produce samples from probability density Px using only the score function here. Given a fixed step size E larger than 0 and initial value x0 tilde sampled from pi x with pi being a prior distribution, Langevin dynamics recursively computes xt tilde from xt minus 1 tilde score and this normal distribution. The distribution of xt tilde equals px when e tends to 0 and t tends to infinity, in which case xt tilde becomes exactly sample from px and some regular conditions. When e larger than 0 and t smaller than infinity, a Topliss Hastings update is needed to correct the errors in the equation above. But it can be ignored in practice. Sampling from the formulation above only requires the score function here. Therefore, in order to obtain samples from p data x, we can further train the score network such that S theta equals this score of p data x, and then approximately obtain samples with Langevin dynamics using S theta to replace score of p in the Langevin dynamics. The basic idea of score matching is shown here. For more details, please check with these references. Thank you. Bye.